know what C is. You don't really know what I is. Sorry, what really I is, or what really money demand function is. You don't know their exact functional forms, right? So you don't know. So we're not going to use C is equal to C naught plus C1 y minus t. We're just going to keep it C, right? So we're going to see that if you don't have any functional forms, how can you use total differential to find slopes? So basically what you mean is an isolar model like this, where C, we're not given the functional form of C. This is C is a function of y minus t. This is not C times y minus t. This is where C is a function of y minus t. I is a function of R. We don't know exactly what functional form there is. Similarly, money demand is a function of R and Y. Again, we don't know what the exact functional form is. So in such an isolar model where we don't have these functional forms, we want to find the slope of RS and LM curve in terms of the various slopes of the functions. We'll find the slope in terms of C prime, which is MPC out to marginal propensity to consume out of disposable income, in terms of I prime, which is the derivative of investment with respect to interest rate. And we'll find the slope in terms of LR and LY, which are just the partial derivatives of money demand with respect to R and Y. So in such an isolar model where you don't have functional forms, you don't know exactly what C is, what I, what L is, we will use the concept of total differentiation to find its slopes in terms of the slopes of the various functions. So first, let's find the slope of the IS curve. So the way you do about it is you take the total differential on both sides of IS equation. So if we go back to our IS equation, so if I take total differential on both sides, the total differential of this would be dy. You have to find the differential of C. We'll look at that in a bit. You want to find the differential of I. So here we can see that I is a function of one independent variable R, and we already looked at this. Let's go back. If you want to find the total differential of a function of one variable, so the total of fx. So for example, if you wanted to find the total differential of this would be f prime x into dx, right? So applying this to the case of R, right? So the total differential of I is just going to be I prime R into dr, where I prime R is just the derivative of I with respect to R, and the differential is G would just be dt. Now let's find the total differential of C, which is a function of y minus t. Now here y minus t is your disposable income, right? So what we're going to do is we're treating y minus t as one variable by d. So total differential of C, y minus t is given to us as, now we're treating y minus t as one variable by d, right? So if I want to find the total differential of C y minus t, that's just going to be, we looked at this now, the total differential of fx is f prime x into dx. So it would be C prime yd into dy dt, where we know yd is just y minus t. So the differential of yd, which is y minus t, is just dy minus dt, right? So differential of yd is just the differential of y minus t, and we know like derivatives, differential of sum or difference is sum or difference or differentials, right? So the differential can go inside this difference, and this can be written as differential of y minus differential of t. So total differential of cy minus t, like we said, is just c prime, which is just MPC out of disposable income times the differential of disposable income, differential of y minus t, which is just dy minus dt. So that's why this is like this, right? So when you're finding the differential of c, just treat y minus t as one variable by d. So now the differential of this c by d is just c prime by d into the differential of yd. And the differential of yd is just the differential of y minus t as dy minus dt. So once we've done that, once we've taken the total differential on both sides of IS equation, now we know since t and g are taken as given, so we're going to set dt is equal to dg is equal to 0. So now we just need to rearrange this to get dr by dy as the slope of our IS curve in a graph with r on vertical axis, y on horizontal axis. So we're just going to rearrange this a bit, right? And so we have dr over here. Then we have dy minus c prime dy. And then from here, we just solve for dr by dy. Similarly, we can find the slope of LM curve. So we'll take the total differential on both sides of LM equation. So if we go back to our equation, so here that this will be the differential of m by p, and here this is a function of two independent variables. And we already looked at, if we want to find the differential of a function of two independent variables like fxy, it's partial f, it's a partial derivative of f with respect to x times dx plus partial derivative of f with respect to y times dy. So here if we take the total differential on both sides of LM equation, so then similarly, when we take the total differential of, of LRY, so this is going to be the partial derivative of L with respect to R times dr plus partial derivative of L with respect to Y times dy. This is what we've done here. Now, since m and p are taken as given, the differential of m by p is just equal to 0. And then from here again, you just solve for dr by dy to get the slope of LM curve, where we when we graph it in a plane with r on vertical axis and y on horizontal axis. So in this way, we can use the concept of total differential to find slopes of ice in Ellen curves even when we don't have any functional forms.